So as James said, my name's Kelly McVeigh. I'm the supervising highway engineer for a group within the New Jersey Department of Transportation called Arterial Mobility Management. And we're responsible for the planning, the design, the construction, and the operations of our advanced traffic signal systems, primarily adaptive traffic signal systems, with some more traditional controlled traffic signal systems. So today I'm just going to explain a little bit more about the arterial monitoring program here at NJDOT. I'm going to give some examples of how we use crowdsourced data for real-time monitoring, how we also use the crowdsourced data for performance measurement, and then I'm just going to have a slide where I talk about some of the next steps where I think we could be headed using data such as crowdsourced data. So a little bit about the arterial monitoring program here. It's something that's been in the works for a couple of years, started with just a handful of us monitoring systems that had been constructed. And we realized that as we expanded our network of advanced traffic signal systems, we would also need to expand our capabilities for monitoring them. So we have an arterial management center at the Trent headquarters at NJDOT, where we have a video wall where we can monitor things like the image detectors. We can monitor the actual data coming out of traffic signal systems. You might recognize some of the graphics there on the right-hand side of that video wall are graphics coming from our SCATS adaptive traffic signal system. And we have a consultant who actually sits in that room from 7 a.m. to 5 p.m. currently, Monday through Friday. And they provide monthly reporting of signal performance, not in a very standardized format. What they'll do is they will generate essentially cases of, PowerPoints describing cases where either an issue was identified, how it was identified, how it was verified, and then what changes were made, and then what was the result. So kind of like a miniature before and after study for each one of the cases. And the crowdsourced data plays a big role. So as James had mentioned, it's definitely a more financially acceptable way of determining what's going on the roadway, as opposed to just completely inundating the roadways with instrumentation out in the field. And so we do have some readers that radar detectors, and we do have image detectors that collect data for us, but we generally use the crowdsourced data. So just to give you an idea of from a network standpoint, what's the size of our network here? So in New Jersey, there's several corridors that have recently been constructed and are in full operation. We're constructing currently about I think that's about 70. I think it's 73 signals in construction, and then we've got 118 signals that are in final design. So we are expanding, as I mentioned before, our advanced traffic signal network. And it's just to give us some context here. Why are we doing this? Well, in New Jersey, traffic, fluctuates quite a bit. So having advanced traffic systems, especially adaptive traffic signal systems, plays a key role there. But even more importantly, there's some specific policies and procedures that we have to follow in the state of New Jersey when determining how to update a traffic signal timing, and what kind of data collection, what kind of effort has to go into actually updating timing parameters. And having an adaptive system makes that process much simpler. So we're able to respond to issues much faster. So on to some of the data that we use in terms of crowdsourcing data. There's two platforms that I'm going to go over. The first one that we use, user interface platforms that we use. The first one that we primarily use is something called the Spattle Tool. I believe it stands for, if I can remember, selected priorities applied to evaluated links. And it's something that's developed by the Transcom Coalition for the New Jersey, New York, and Pennsylvania, the tri-state area. So we will use that in terms of real-time monitoring. There's, a map interface, much like if you were to log into Google Maps or any other mapping application, and you can see things, such as the current speeds. It also provides some good information like what is the speed historically, so we can get a good idea of, is this something that's normal? Is it something that we need to now look at our cameras, look at additional data, from the traffic signal system? Is our traffic signal suddenly trying to increase its cycle length out of the norm? And why? Oh, there's a lot of congestion here that is not historically there. So it's a useful tool. And it also is interesting because it provides some information on the data source, and I'll get to that in a slide. Here's just another example of the same type of data. It's a dashboard that we'll have. Generally, we'll have the dashboard on one of the computers in the Arterial Management Center, and we'll have our corridors. So this is an example of one of our corridors, Route 18, and specifically in the northbound direction. So we know if there's directional, if there's a priority direction that we want to focus on, we can very easily set that up. And setting up a dashboard like this, once the data is in the Transcom Spattle Tool, setting up a dashboard takes, about a minute or so. You just have to select the links you want, maybe 5 minutes if you're looking for the links. And again, it provides a lot of good quantitative data here. What's the current travel time? Historically, what is it? Gives you delta. That's what you see in the incident delay column. That's the difference between calculated travel time and historical travel time. And then you can also see, is it close to free flow travel time? What's being measured, around midnight, 1 o'clock in the morning, 2 o'clock in the morning? And is that comparable to what we see here currently? So as I mentioned, there's several data sources. And so one of the unique things about the platforms that we use, especially the Transcom Spattle platform, is an agency that is subscribed to certain data sources or, has certain data sources. Transcom will set up an API to connect to the original data source feed. So for example, the TrafficCast Bluetooth data that comes from their travel time re-identification Bluetooth readers. And so Transcom will actually take that data in. We will inform them where it is, so what roadways, what mileposts, and then that will become an additional layer within their data fusion engine is what they call it. And really it's like a data layering engine, meaning they're able to, on one section of roadway, a user can see what is the Bluetooth travel time versus the here Navtech, previously Navtech travel time, INRIX, if they have census pucks in the ground, and then, Traffic Now data, which is another vendor that provides a product called Deep Blue, which is re-identification Bluetooth reader data. And so there's several data sources that can be used, and a user can actually go and select those sources specifically to see where they are throughout the state. So you'll see little, if you look at the map of New Jersey, little speckles of Bluetooth TrafficCast data versus more, a fuller coverage of, INRIX or Navtech. Another platform that we also like to use, not as much from a real-time performance monitoring, but I just want to show that it's similar in sense that we do have the ability to create dashboards as well. And this is using the Probe Data Analytics Suite platform that is developed at the University of Maryland, the CAT Lab. And so here you can see, very similar to that dashboard I showed before, this is showing us very specific locations. In this case, I did both northbound and southbound. And for this dashboard, as opposed to what we do with the Transcom Spattle platform, using this platform, we have taken our INRIX data that we subscribe to, and that's what New Jersey is able to access through the Pro Data Analytics Suite. So now just moving on to some performance measurement. How do we do this? So pretty straightforward. I put a flow chart up here just so you get an idea. But vehicle probe data is great for identifying issues. When you're looking at it in real time, especially in a map application, especially when you have access to a layer that tells you what the historical data is, it's a very useful tool for someone to just look at a map, whether they're a traffic engineer, an operator, could be someone in administration just walks in and they go, man, something is going on there. It doesn't look right. It is very intuitive. So we identify issues. We also, if we get a complaint or something, we can use this data to verify that. We make changes to our system. So I mentioned we can respond very quickly. We can say, hey, this is going to require more bandwidth for our main line. We need to get a southbound progression pushed right away. We go in, we make changes. And then what we'll do is we'll look at how the vehicle probe data has changed. So we measure it. And one of the benefits here also is that these platforms keep this vehicle probe data historically. So it's easy to say, okay, we made a change. We know what time we made the change. Now let's go back and take a look at what it looked like before. And then we can go back and update the system again if we have to, if it seems like the change we made hasn't had as much of an impact. So a little bit more about the Probe Data Analytics Suite. We use this more, as I mentioned before. Spattle is a good operational tool. We also use that for performance measurement, just to pull some simple travel time graphs and things like that. The Probe Data Analytics Suite has several widgets, I believe is what they call them, widgets, but one of them is called a bottleneck ranking tool. And we really like this because you can, as the user, just say, hey, I want to see what the worst bottlenecks are. And you can do it by county, you can do it by multiple counties, you can do it by roadway, however you want to select it. And we'll go in and do this generally once a month or once every 2 months. And we'll see what are our worst bottlenecks, when are they occurring. And you can see here that for this, in this example, this is Route 73 southbound at Marlton Parkway. It's a key bottleneck intersection for anyone local to the Burlington County area of New Jersey. And you can see that it primarily is happening in the latter part of the day. It's not really an AM peak issue. So when we go back into our adaptive system, we can see what are the parameters that we're using, what's the parameters that the adaptive system is selecting based on these various times a day. And then we can start writing certain rules within the adaptive system to say, okay, during PM peak, we're going to go ahead and do XYZ when we measure, ABC. And we've actually had some success here, measuring volume leading up to the PM peak. We've made some adjustments at this intersection, and we had seen in a before and after about a 45% reduction in travel time from the Route 70 interchange down through Marlton Parkway, which was a pretty good improvement. And then just one quick case study to give you an idea, just a little bit more visual on how we use this data. This is a performance measurement example. So we had known that there's an issue on Route 1. This is Route 1 northbound approaching New Road in South Brunswick Township, which is in Middlesex County. So Route 1 is a principal arterial that runs parallel to the New Jersey Turnpike. And we knew during the PM peak in the northbound direction, there was some congestion that was building that we could see via cameras. There's a lot of cameras on Route 1. And also the probe data was helpful in verifying that. And so what did we do? We used the Spattle. These are snapshots from the Spattle tool where we can select the links. So when we're very specific in the links that we need to select, the Spattle tool is good because it's a little bit more granular than the Probe Data Analytics platform. And what we did was we picked the northbound link, and knowing that we were going to make a change to Route 1 mainline that could have a negative impact to the side street route, we also selected the westbound approach link on the side street, knowing that was the primary direction on the side street there in terms of traffic volume. And so we made a change, and then we were able to go back and do a before and after study. And I like to show this because sometimes you make the change and you think, yeah, you know, it looks better. It looked like, you know, a couple of times that we saw it through cameras with our own eyes. We're like, okay, it's better. But then you go back and you see this data and you're like, okay, well, at least on this day, this Wednesday, June 8th versus Wednesday, May 25th, there really was no improvement, at least not that we could see using this data. Then we looked at the travel time for Thursday. So it was Wednesday, then Thursday, and we did see that on Thursday there seemed to be a bit more of an improvement. And we had kept our eye on this for a couple more days and saw that it generally had improved, the main line travel time northbound approaching that intersection on that link. And so that was good. And so we wanted to see what happened to New Road. And, you know, you can see that there's essentially around that same time, there really is not much of a difference on New Road. I mean, a 3% difference when your travel times a little under 1.5 minutes is not too much for that link, especially when it was it's that entire link approaching Route 1. And then we did see a little bit of an increase in the travel time when looking at Thursday. So that improvement that we saw on Thursday on Route 1 northbound, you can also see a slight degradation here for the side street approach on Thursday as well. And then the last slide I have here is just some of our next steps. We're really starting to focus on how to automate a lot of this. So currently we have so much data. These platforms automate the data in terms of being able to look at it when we want to in a user interface, but finding ways to then be able to spit out produce a report that we can then show. I currently have, if I had to guess over the last year, I might have about 25 to 30 PowerPoints that explain these various cases where we made some changes here and there and we saw these improvements. Quantifying that at a high level for management is an important next step. And so we started looking at the ATSPM platform. I really like what I've seen Georgia DOT do with Kimley Horn in terms of the SIGOPS metrics. Used to be called the Mark, I think it was called Mark IV platform, but now called SIGOPS. And then what you'll get to see in a few presentations, Allyson in the I think it's the Austin area, the platform that they have in terms of their reporting capabilities is something that New Jersey is very interested in. And so we hope to find more information on how to make that happen. And with that, thank you.
Great. Thank you, Kelly. Great presentation, packed a lot of information in there and covered a lot about how you're using crowdsourced data, both in real time and in an archive measurement manner. So thank you. I see a couple questions. Kelly, you'll be able to stay on at the end and we'll do our Q&A and can address a couple of these questions that we have for you. So thanks, Greg and Mohan for putting questions in the chat pod.